Welcome to physics class. Today we will learn about the graphical representation of motion. First of all, definition of a graph: a geometrical relationship between two quantities plotted on the x and the y axis is called a graphical plot or simply a graph. When you see, you learn faster and understand better. The data from any measurement can be made more informative when presented in the form of a graph. One of the two quantities to be plotted can be changed independently while other depends on it. The quantity which can be changed independently is called the independent quantity, while the other which depends on it is called dependent quantity. Generally, the independent quantity is plotted on the x-axis and the dependent quantity on the y-axis. For example, if we want to draw a graph between number of runs scored and the number of overs played in a cricket match, then the number of overs is the independent quantity and numbers of runs scored is the dependent quantity. It is clear from this graph. Drawing the axis. If both the quantities to be plotted are positive, then draw two perpendicular lines intersecting each other at the point. This point of intersection is called the origin. The horizontal axis is called x-axis, while the vertical axis is known as y-axis. If one of the two or both the quantities are negative, then the axes are drawn so that the origin is in the middle of the paper. While plotting, it should be remembered that all positive quantities are plotted on the right and upward of the origin, and the negative quantities are plotted on the left and downward of the origin. The independent quantity is plotted on the horizontal OX or OX-axis, and the dependent quantities is plotted on the vertical OY or OY-axis. Label the two axes accordingly. Distance time graph. A moving body changes its position continuously with time. The simplest way to describe the motion of a moving body is to draw its distance time graph. Distance time graphs provide information about the position of the moving body at any time during its motion. What is a distance time graph? The geometrical relationship between the distance traveled by a body and the time taken is called distance time graph. The slope of the distance time graph is equal to speed of moving body. Thus, speed of a moving body can be obtained from its distance time graph. Distance time graph for uniform motion. If your body travels equal distances in equal intervals of time, then the motion of the body is known as uniform motion. All the points in this graph fall on a straight line which makes an angle with x-axis. Thus, the distance time graph of a body moving with a uniform speed is a straight line making an angle with x-axis. In other words, the distance traveled by a body moving with uniform speed is directly proportional to time. Conclusion: distance time graph for the uniform motion of a body is a straight line having a constant angle with the time axis or constant gradient or slopes. Slope of the graph AV covers the distance s2 minus s1 in time t2 minus t1. So speed can be represented by the formula v equal to s2 minus s1 divided by t2 minus t1. We can plot this graph for accelerated motion also. In table 8.2, distance traveled by a car at regular time interval is given. Time in seconds, there is a gap of 2 seconds and the distance is also given. We will see the graph on the next page. If a body travels unequal distance in equal interval of time, then motion of a body is known as non-uniform motion. When the speed of the body increases with the passage of time. For example, when a train leaves the platform, its speed increases with passage of time. That is, the train covers more and more distance in unit time. Distance time graph for such non-uniform motion of the body is shown in the graph here. Conclusion: distance time graph for the non-uniform motion of a body is a curve having increasing slope or gradient. The speed or velocity of such a body changes with time and hence the motion of the body is accelerated motion. Distance time graph for a stationary body. The distance of a stationary body from a fixed point does not change with passage of time. It means if distance of a stationary body from fixed point, say O, is 4 meter at time 0, then the distance of this body will remain 4 meter for all time. Distance time graph for a stationary body is shown in the given graph here. Conclusion: distance time graph for a stationary body is a straight line AB parallel to time axis. Velocity time graphs. Velocity time graph shows how the velocity of a body changes with passage of time. To draw velocity time graph, velocity of the body is plotted along y-axis and the time taken by the body is plotted along x-axis. When a body moves with constant velocity, that is, its motion is uniform, its velocity does not change with time. Velocity time graph of a body moving with constant velocity is a straight line parallel to time axis. We can find out the distance as moved by a car in time t2 minus t1 expressed as s equal to AC into CD. It is area of the rectangle ABCD shaded in the previous graph. Table 8.3 Velocity of a car at a regular instant of time is given. Time lot 0, 5, 10 means gap of 5 minutes over here, and velocity of car is given in 2 units, meter per second and kilometer per hour, and we can observe equal distance is covered in equal interval of time. That is the example of uniform motion. Now for these given values, we will see the graph. Velocity time graph of a body having uniform motion initially at rest is a straight line passing through the origin and have a constant slope or constant gradient. Straight line sloping upward and passing through the origin, slope of the straight line is positive. Therefore, the body moving with a uniformly increasing speed or velocity have uniform acceleration. And the distance traveled by the car in the given example discussed here can be calculated by the area under diagram, that is the shaded area A, B, C, D, E in this velocity time graph as equal to area of ABCDE, that is area of rectangle ABCD plus area of the triangle ADE, that is AB into BC plus half AD into DE. Likewise, we can calculate the distance traveled by the car in the given time. When the body is moving at a certain velocity or speed and the velocity or speed decreases uniformly with time, straight line sloping downward, slope of the straight line is negative. So, the acceleration of the body is negative. In the other words, body is under uniform retardation. It is clear from figure 8.7a part. Speed time or velocity time graph is zigzag curve. The body is under uniform acceleration and retardation alternatively. It is clear from B part figure 8.7. Both are examples of non-uniform motion. Page number 107, question 1. What is the nature of the distance time graph for uniform and non-uniform motion? So answer to this question: distance time graph for uniform motion is a straight line. Distance time graph for non-uniform motion is a curve or a zigzag line. Question 2. What can you say about the motion of an object whose distance time graph is a straight line parallel to time axis? Answer: the object is stationary. Question 3. What can you say about the motion of an object if its speed time graph is a straight line parallel to time axis? Answer: the object has uniform motion. Question 4. What is the quantity which is measured by area occupied below the velocity time graph? Answer: displacement. You have to write answers to these questions in your notebook. Thank you for watching.